Find the exact values of m for which the line y equals mx plus 5 is a tangent to the curve x squared plus y squared equals 10. To solve this, we know that this line has to be equal to this curve at a point, so we're going to solve them simultaneously. What that means, we're going to substitute y into this equation. So we're going to get x squared plus mx plus 5 squared equals 10. Expanding this, x squared plus m squared x squared plus 5mx plus another 5mx is plus 10mx plus 25 is equal to 10. Now this has got x squareds in it, it's a quadratic equation. I'm going to rearrange it slightly. So combining these x squared terms, I've got m squared plus 1 times x squared plus 10m times x plus 15 is equal to 0. Here is my quadratic equation, and given that it is a tangent to the curve, the tangent means it just touches once, which means the solution to this intersection only has one solution, so the discriminant is equal to 0. If the discriminant is equal to 0, that means the discriminant here, b squared, is 10m squared minus 4 times a, which is m squared plus 1, times c, which is 15, and we know that is equal to 0. Expanding this, we get 100m squared minus 4 times 15 is 60, so we're going to get minus 60m squared minus 60 is equal to 0, which means 40m squared is equal to 60. M squared is equal to 60 divided by 40, which is 3 over 2, which means that m is equal to plus or minus the square root of 3 over 2. So there are two values of m where this would be true. The positive square root of 3 over 2 and the negative square root of 3 over 2. So let's visualize this problem. We have our curve and y equals mx plus 5. As we change the value of m, the y-intercept stays the same and the gradient changes because m is the gradient. Now if I reveal this curve, you might recognize that this is a circle of radius the square root of 10. Here's our circle. And we're looking for the points where this green line is a tangent to that red circle. So we can see if we go that way, not going to do it, is as we go this way, it gets closer and closer, about there, somewhere between 1.2 and 1.3. And similarly on the other side, somewhere between minus 1.2 and minus 1.3. Now we calculated that it was the square root of 3 over 2, or 1.5. So if we type in here the square root of 1.5, we can see that at that value it is exactly the tangent. It touches just one time. And similarly, if we made this negative, we would get a tangent on the other side where it touches just that one time there. So this one would have been impossible to find by trial and error because this is a non-rational number. So using algebra is the only way we can actually find the exact value of this value of m that works perfectly.